These are notes for section 6.1, day 4, quotient properties of exponents. Now, the simplified version of this is something that we all know in a very basic concept. 2 divided by 2 is 1. 4 divided by 4 is 1. 7 divided by 7 is 1. It's going to boil down to this kind of idea that we all are very familiar with. And again, we'll come back to writing it out in product form to see how we get our shortcut or the rule for understanding exponents in quotients, division. X to the 7th in our first problem would mean that I have 7, or 8 to the 7th, I said X. 8 to the 7th would mean I have 7 eighths. 1, 2, 3, 4, 5, 6, 7. Divided by 8 to the 3rd. That would be 3 eighths. 1, 2, 3. Now, again, if I come back up here and understand 2 divided by 2 is 1, 4 divided by 4 is 1, 7 divided by 7 is 1. So what I have is 8 divided by 8 is 1. 8 divided by 8 is 1. 8 divided by 8 is 1. So what I have left is 8, 1, 2, 3, 8 to the 4th, 8 to the 4th. Because the other 8s are equal to 1. 8 divided by 8 is 1. X to the 3rd, that's x times x times x, divided by x. Again, x divided by x would just be 1. Take a number divided by itself, take a variable divided by itself, you would just get 1. So you're left with x squared. And the last example here, that's 10 to the 5th, that's 10 times 10 times 10 times 10, divided by 10 to the 3rd, 10 times 10 times 10. Well, 10 divided by 10 is 1, 10 divided by 10 is 1, 10 divided by 10 is 1. We're left with 10 squared, or 100. So how can we see to get from our exponential form here and not write it out in product form to end up there? How can I get from here to here? How can I get from here to here? Well, as it says below, when you divide by the same base, you can subtract the exponents. So 7 minus 3, 8 to the 4th. 3 minus 1, x to the 2nd. 5 minus 3, 10 squared. So this is kind of the opposite end of, if you multiply by the same base, add the exponents. If you divide by the same base, subtract the exponents. So if we go through a couple of examples here, I could write all of these out, x, start canceling them out, or I could just subtract. 9 minus 7 is 2. 5 minus 2 would give me 4 to the 3rd. 3 minus 1 would give me y squared. 15 minus 2 would give me 3 to the 13th. And again, you could write all of these out to show it, to prove it, or we did that at the top of the slides, and that's how the exponents of quotients operate. 7 to the 7th minus 7 to the 7th would be 7 to the 0. This is something that needs to be discussed in another video. We'll just leave it as that for now. 3 minus 2 would be 5 to the 1st. 4 minus 2 would give me z to the 2nd. And 7 minus 3 would give me, I don't think I can make that into a 2. 2 to the 4th. 2 to the 4th. The next property is the power of a quotient. If you remember, we have the power of a product. Now we're having a power of a quotient. And again, to understand this, if we write this out in product form, I have 2 of this entire factor inside the parentheses. So I have 2 x squared y to the 3rd over z times, because that's what the exponent means, I'm multiplying, and x squared y to the 3rd over z. Now the rule is, if you multiply by the same base, add the exponents. Multiply by the same base, add the exponents. Well, I am multiplying x squared and x squared, that's x to the 4th. I'm multiplying y to the 3rd, that's y to the 6th. And I am multiplying z times z, which is z squared. So multiply by the same base, add the exponents. That was day 1 of exponent properties. And again, last example here, I have ab squared 2c to the 4th, all raised to the third power, which means I have 3 of these things inside. So that's ab squared 2c to the fourth times ab squared 2c to the fourth times ab squared 2c to the fourth. I have 3 of those. Okay, so if you multiply by the same base, which I am multiplying, multiply by the same base, add the exponents. A to the third, b squared, b squared, b squared, b to the sixth. 2 times 2 times 2. 2 times 2 times 2, that's 8. C to the fourth, c to the fourth, c to the fourth, that's c to the 12th. Multiply by the same base, add the exponents. So how could we, again, get from here to here without actually having to write out product form? And that rule is if you multiply or have a power of a quotient, you multiply each exponent on the inside by each exponent on the outside, which is identical to a rule that we had previously. If you remember, a previous rule is if you have exponents on the inside of the parentheses, you multiply each of those exponents, x to the 8th, y to the 12th. Well, this is the exact same rule, but now instead of it being a product, meaning multiply, now it's a division, meaning a quotient, but it's the same principle. So if we use that property, this exponent of 2 on the outside is going to multiply all of the exponents on the inside. 2 squared, x to the 8th, 5 squared, y to the 6th. That would be 3 to the third. I'll talk about the negative here in a minute. 2 to the 6th. That's taking this 3 and I'm multiplying all of the exponents. X to the 6th, y to the 9th. Now, this negative belongs to the exponent of 3. This negative here belongs to the exponent of 3, which means I have 3 negatives. 3 negatives would make my answer negative. And on the last example, I take this 4, multiply each of the exponents. 7 to the 4th, a to the 8th, b to the 12th. And again, we could write all of this out and then just boil it all the way down to multiply by the same base, add the exponents. Hopefully that helped. I'll see you on the next one.